Okay. So yes, as a data scientist, or as a data science practitioner, you may have, or I myself, I have also was scratching my head when trying to choose the best machine learning algorithm for my projects. Okay, so with so many options available, okay, we have so many options available outside. The process is like just like too much and confusing, overwhelming also. So during that kind of situations, like as a beginner, you will frequently meet plenty of data sets. Okay, you will frequently meet plenty of data sets, like where you will ask yourself, like, what is the best approach I should follow so that I can solve my particular problem in that data set, in the given data set I have. So what techniques or algorithms should I apply there? Okay, so this is what we will be covering in this session. So let us go with the agenda of today's session. So we are going to see the solutions to what a machine learning algorithm is attempting to achieve, and what are the keywords is which is very important in choosing an algorithm, and to understand the different categories of algorithms, and like how you will be equipped to choose the right one for your project and move forward so with the proper good confidence, I'd say. So that is what we are going to see. And let's start by answering this question. Okay, let us start by answering these questions. These are like the fundamental questions. Okay, so like you might get the questions like, what is a machine learning algorithm trying to do? Okay, you might get this question like, at its core, you might also question like, any algorithm aims to take a set of features and translate them into the like useful prediction using a mathematical system. Okay, useful prediction using a mathematical system which is unique to that particular algorithm. So therefore the translation process is can vary differently, widely. So in the machine learning world, there are like three techniques, especially, that is the classification, regression, and clustering. Okay, so typically classification and regression are coming under the supervised machine learning. Okay, supervised machine learning. So here today in this today's session, I'm just going to talk about the machine learning and the models, algorithms directly. I'm not going to explain about the supervised or unsupervised here, but then I hope you guys know what is a supervised machine learning or unsupervised machine learning, which I'm trying to explain now. In case if you have no idea regarding that supervised or unsupervised, you can just go take the videos which is in the older previous sessions, and you can have an understanding there regarding that. Okay, so here when it comes to the machine learning world, we have the classification, regression, and clustering techniques, three important techniques. So typically classification and regression are coming under the supervised machine learning algorithm, and clustering is coming under the unsupervised machine learning algorithm. So in the supervised machine learning, what will happen, your label you label your data set for the training model. You are going to give a label for that model. So label data set means that each sample in the training set has a corresponding answer for that algorithm, and which is also called the ground truth or the label. Okay, so in our fintech case, like the answer is either the loan application, like many of the time that is what the example they will take, like loan application has paid the loan or defaulted. So these kind of machine learnings, and the machine learning algorithms which performs predictions and compare them with the actual values. It will perform a prediction and it is going to compare them with the actual values. So that is nothing but the ground truth. So the difference between the prediction and the actual is the error. Okay, how will they say the error is found out? So difference between the prediction what the machine learning has got with us, and the and the actual what it is there. So that is the error that the machine learning try to minimize through the learning process. So machines are learning, right, through the learning process. So in an unsupervised machine learning, what is going to happen, you don't provide any explicit answers to that model. Okay, instead what you're going to do is your machine learning algorithm will try to independently find the correlations in the data automatically. It is going to do it by itself. So the difference between the regression and the classification algorithm is that the regression algorithm is going to predict the continuous values. So you all might know what is a continuous value, such as like we have price, we have precipitation, we have the age, and so on. right? And in contrast, the classification algorithm predict the category value, like an observation that belongs to such as a gender, kind of whether male or a female. Purchase, when I'm going to purchase of the customer will buy this product or not, will buy this product or not, email is going to spam or not spam, and so on. So the clustering algorithms are also there, which are used to identify the classes and the groups. So these are all coming under the machine learning algorithm. So now we are just going to say like, so what's the keyword that plays a major role in selecting an algorithm? Okay, so here it's simple, like the features themselves. Okay, the features themselves are going to be the keyword. So you are just trying to choose the best algorithm, or we can say in simple words, in generic word, we can say a translator, a proper translator for your specific set of features which you have got. So in this session, we'll also break down the most widely known algorithm based on their general behaviors, like by understanding the different categories of algorithms, so you will be well equipped to choose the right one for your project and move forward. Okay, so here the first concept which we are going to talk about is in while what is the keyword coming under, in that we are going to see is the decision boundary concept. What is this decision boundary concept? So it's like when I want to come to a decision, okay, which model I want to select for my particular data set, given data set which I have. So it's crucial to have a clear understanding of the decision boundary concept. So what we will do is, the decision boundary is nothing but it is going to define how an algorithm behave and how it interprets and how it processes the data. Okay, so here it is, the decision boundary is nothing but it is like, it is very essentially, it is going to highlight the strength of each algorithm. Okay, providing the valuable insights into their performance. So it's like understanding this decision boundary concept is very, very, very essential for selecting the best algorithm. Okay, best algorithm for a particular data set which you have been given. So by knowing how an algorithm behaves and how an algorithm interprets the data, a data scientist can make a very good informed decisions, and he can choose the right algorithm for their specific needs, right? So for instances, so people who might have known these algorithms, they can understand what I will be trying to say now. It's like, for instances, we have the k like the k nearest neighbor algorithm. We call that as a KNN algorithm, right? So it, what does it do? It mainly relies heavily on the proximity of the data points. Like while we have the linear support vector machine algorithms, so while the linear support vector machine algorithm, it is going to, it tries to slice the data to determine the class of each point over there. So this support vector machine and neural network, what it is going to do, so both will aim to find the linear combination that is going to separate the data, but then it is going to use a different method to achieve this goal, right? So every algorithm has their own way, has their own rule to achieve a certain goal over there. When it comes to the decision tree or the random forest algorithm, so what those two do, those two algorithms both use a strategy of splitting the data sets to separate classes, right? Separate classes. With random forest, it is going to take an approach furthermore. So meanwhile, we also have something, other algorithm which is called as AdaBoost algorithm. So that AdaBoost algorithm, it is going to enhance and it is going to modify the idea of this, modify the idea of the splits to improve the performance. So by categorizing an algorithm based on their behavior, okay, we can make very, very good informed decision when selecting the right algorithm for our needs there. So understanding how an algorithm processes and it is going to interpret the data is very crucial. How the algorithm is going to process and how it is going to interpret the data is the important point when it comes to selecting an algorithm or choosing the best algorithm for a particular data set. So when this is in our topic of discussion of which we are discussing, we have in the decision boundary, we have the linear models, tree based models, and distance based models. So let us take a small understanding about what is this linear model or tree based model and the distance based model one by one. When it comes to the linear model, okay, so we have a linear model. So what is this linear model? So in machine learning, a linear model is nothing but it refers to a model that is specified as a linear combination. Here I'm not going to do anything practical. Okay, here I'm just going to give you the theoretical concept. So once you have understood the theoretical idea of that particular model, then you can go forward and check with how it works practically. So in the machine learning, when it comes to the linear model, it is going to give us linear combination of the features. Okay, so during the learning process, machine learning is like it is going to learn from the experience, right? So during the learning process, the algorithm computes a weight for each feature based on the training data, and to form a model that can predict or estimate the target value, right? So essentially, the linear model uses a linear equation to represent the relationship between the input features and the output value. Okay, it is going to check with the linear relationship between the input features and the output value. How it is going to represent that particular relationship? It is going to represent by adjusting the weights of each features. Okay, adjusting the weights of each feature so the model can accurately predict the target value for the new input data. So the linear models are like widely used outside in various machine learning applications like regressions and many other classification problems as well. Okay, so next we also, when it comes to the linear regression models, in linear regression models we have like logistic regression, support vector machine algorithm, and neural networks here. When it comes to the next kind of a model, that is tree based model. So what is this tree based model all about? So the tree based models are a kind of a category of a machine learning, one of the algorithm that is, it is going to use the series of if then rules. So if you have learned the Python programming language or any other programming language, so there is a concept of if then rule, right? So this tree based model is completely working on that particular if then rules only. Okay, all the tree based models. So if then rules, it is going to work with that if then rules, where it is going to generate the predictions from one or more decision trees. Okay, one or more decision trees. Like this is nothing but the result in splitting the effect that can be seen in the graph, it is going to it will be represented in the form of a graph there. So a decision tree is a kind of a graphical representation. When it comes to a decision tree, it is a kind of a graphical representation of the rules that a tree based model use to make a prediction. Okay, it is like decision tree models are nothing but it is narrowing the way for us so that we end up with a good decision. So the tree starts with a single node. Okay, we have, it is just like a tree. So it starts with a single node which represents the entire data set, and then it splits it into branches. So that is a decision. Okay, that branches, it is going to split, right? Yes, no, that will be the decision, yes or no decision. And that represents that represents the data sets, which has been the subsets of the data sets based on the particular feature. So the process is repeated until each subset contains only one class of the data, until it is ending with one decision. Till then, the tree keeps on producing its branches. That is the main concept of the tree-based models. So there are like several popular tree-based models with us. Like we have the decision tree, we have random forest, we have gradient boost trees. Okay, so in these things, like in these algorithms, the decision trees are like a very simple and easy to interpret. We have decision tree, random forest, gradient boost trees. So among these, we have decision tree, which is like a very simple and it is also easy to interpret. Like we have random forest. What it will do is it will combine the multiple trees so that it is going to improve the accuracy and reducing the overfitting. So these random forests are nothing but the are nothing but they are just combining all the weak models so that they get into a stronger decision. So it will just define multiple decision tree. If from that decision tree it is going to create a forest in which the complete strong decision which we are going to get there. So here when these random forests combine multiple trees, so that it is going to improve the decision, and it is also going to reduce the overfitting of the data. And the next one is gradient boosted trees. So what are those like iteratively it is going to improve the decision tree so that it minimizes the errors and increases the accuracy. So every model has its own limitations and advantages also. So basically tree based models are widely used in various machine learning applications like classification and regression problems. So like even this tree-based model, it categorizes like this category also includes the different algorithm like decision tree, random forest, like we have XGBoost, GBM, and we have boosting. We call this as an ensemble method. So ensemble methods. So these are all the ensemble methods from random forest. Okay, from random forest, these are all the ensemble methods. So ensemble method is something, right? It is ensembling. It is assembling all the decision tree is one model, random forest or all the ensemble methods are something with one decision tree, like two or more decision tree, they are going to ensemble it, and they are going to combine all the weak models and get as a strong model. So that is a tree based model. Then the next one is distance based models. So what are these distance based model? So distance based models are like they are the category of the machine learning algorithm that is going to determine the decision boundary based on the closeness of points to each other. Okay, closeness of points to each other. So when it comes to distance based models, okay, distance based models, like the most popular distance based models are like k nearest neighbor. Okay, k nearest neighbor. In the name itself, the nearest neighbor, nearest, the distance is mattering there, right? So the most popular distance based model is the k nearest neighbor, KNN algorithm, we call it as. So these KNN algorithms, they find the very closest k data point. Okay, so closest data points to the input, and it is going to predict the output based on the majority of the neighbors. Okay, majority of these neighbors. So another popular algorithm in this category is naive bayes algorithm. Okay, which in the naive bayes algorithm, which is going to predict the probability of each class given the input features and uses the Bayes theorem to combine these probabilities. So it is completely based on the Bayes theorem. So what is these distance based models? They are like mostly used in various machine learning applications like classification, regression problems, and these models are a bit sensitive. They can be very sensitive to the scale of features, and that we also have the data normalization or standardization, like which is often required to improve their performance over there. So when selecting a machine learning algorithm, what you should do is it's very essential to understand the relationship between the feature and the target values. So we might have multiple features, and in that multiple features we should also decide what is the target value. Which is the target value? You should differentiate the feature and the target value. So when you do this, this can help many of the data scientists to choose the right model for their data so that they can accurately predict the target which they have kept. So based on the categorization of the machine learning algorithms, it is very like kind of a very simple question arises everywhere, like, are the features in our data helpful for creating the splits between the classes? Or we can also get a questions like they like, are they more useful in creating linear trends between the features and the target value? Right? To answer these kind of a question, a data scientist should perform exploratory data analysis. Okay, a data scientist should perform exploratory data analysis. So that is the next approach. Okay, that is going to be the next approach. So these exploratory data analysis is very important. So when I want to find the answer, or when I want to decide whether my model is going under the linear model or a tree based model or a distance based model, okay, the first thing what a data scientist should do is that he should perform the exploratory data analysis. So he will be able to understanding the relationship between the features and the target value. Okay, so they can use visualizations and statistical methods to analyze the data, and they can also identify the patterns and the trends in the data. So if a feature show a clear relationship with the target value that can be expressed linearly, what is going to happen? A linear model can be appropriate. Okay, if I have a data set in which I have the features and the target value where their relationship is clearly expressed in that particular data set, so I don't have to worry, I can go for a linear model with that might be appropriate. Like I can also say on the other hand, if a data requires splits to separate the classes, so when I feel like my data is going to require a split by separating their classes, so during that kind of situation, I will go for a more suitable model, that is a tree based model. So in the tree based model, which is suitable one, I will go for that one. So by considering the behavior of each algorithm and understanding the relationship between the features and the target value, a data scientist or a data analyst can choose the right machine learning algorithm for their data so that they can achieve the this particular predictive performance. This EDA, which we are talking about, exploratory data analysis, it is like a cornerstone of a data science. Okay, they call it as a cornerstone. So what is its main goal? Exploratory data analysis, so its main goal, that is ultimate goal, is to know, or it is just to explore, or it is to visualize your data to make a very good informed decision. So by understanding your data, exploratory data analysis can help you decide on the best algorithm of your model. So while there are like no clear cut process for exploratory data analysis, we can summarize the essential steps to reveal the valuable insights. Okay, so there is not a proper process for this exploratory data analysis, but then what we can do is we will try to summarize what all is very important when it comes to these exploratory data analysis, which is going to become a valuable insight for us. So the first in this we have two steps basically. Okay, in this we have two steps. So in the exploratory data analysis, the first step is nothing but summary statistics and visualization. Okay, first step is summary statistics and visualization. So summary statistics we all know, right? By looking into what is the percentiles, what is the ranges, what is the variance, all the statistical informations, what is the standard deviation. So you can identify the range for most of the data. So average and the medians is going to describe the central tendency of the data. While we have also the other statistical analysis like correlations, which is going to indicate the relationships, strong relationships in the data, whether they are whether they are correlated to each other or not, strongly correlated, weakly correlated, positively correlated, negatively correlated. So these kind of informations I will get from the summary statistics there. And the second step in the EDA is very important step, that is visualize the data. Okay, so we have many kinds of visualization. Box plots are available so that I can identify the outliers in the data. So we will see the outliers also. So density plots are also available, and histograms are available, which is going to show how the data is spread and how the data is scattered, and it is going to give the relationship between the features and the target variables. So the insights which is gathered from these two steps will contribute to model selection, right, by identifying the range, central tendency, and the relationships in your data. So what is going to happen is you can determine which algorithm is best suited for your model, and it's also about exploring your data thoroughly, and it is you're just going to make informed decision based on what you find from that particular data. So in these two steps, that is summary statistics and visualization, and visualize the data, these two steps, i I could come to a conclusion what is a main target which I should correct when it comes to this exploratory data analysis. So now let's like we will just see the outcomes of these two steps. When I do the exploratory data analysis, that is summary statistics and visualization, I will get some different outcomes from these from the steps which I am mentioning, right? How these two steps are contributing to the model selection. Okay, how the first one is outliers. Depending on this also, we are going to select which model. So when I perform an EDA, exploratory data analysis, outliers are there. So outliers, what are outliers? So they have a very large impact on any linear model. Okay, when it comes to the linear model, when we are trying to do a linear model, it has a very large impact, since the model will try to match the data points with high weights there, right? So this can have an impact on the model's accuracy and raise some critical considerations there. So when you find that your data set is having outliers, you should handle the outliers. Okay, so the first, given the presence of outliers, if you have the outliers with you, like, would a linear model be appropriate? The linear models are based on the assumption that the data is regularly distributed and free of outliers. So when I perform the exploratory data analysis and I found there are outliers, when there are outliers, I can come to a kind of a narrowing my decision there. When outliers are there, I cannot go with the linear model. Hence, like, they may not be the best choice for data like containing large outliers. So if my data is having a large outliers, I cannot go for a linear model. Okay, the linear model which we had mentioned earlier. So if the outlier continue to exist, what will you do? The challenge becomes how we are going to deal with them. Okay, outliers can be dealt with, like, you can remove them from the data set if you want. Okay, so this strategy, when that is you're removing the outliers, this strategy is like dangerous, because it is going to result from the loss of vital information. What if the outliers which you're going to remove is the like the very important information which you have in that particular data, right? So this is a bit of thinking we will have to think about before we remove the outliers. And another method is to transform the data using the logarithmic like a logarithmic transformation or a scalar transformation. Okay, square root and logarithm transformations are there. I can use that and I can handle the outliers there. So this is the first thing. So when I perform the exploratory data analysis and I come in with these outliers in my data sets visualization, I found in the box plot, I found the outliers present, then I should decide the linear model will not be the best approach. Either I will have to deal with the outliers and then go with the linear model. Sometimes when you're removing the outliers, when the outliers are more, what is going to happen? You're going to lose, like, underfitting of the data is also happening. The data should be optimum to train. The data should be very much optimum to train. So when the data is less, it will be very difficult for you to train the data. So removing the outliers is a bit of concern. So that, but the other approach is that you can go for a kind of a applying the logarithmic or scalar transformation for your data sets. The next kind of information which we get from the EDA is data distribution and correlation. Okay, data distribution and correlation. So what is this data distribution and correlation? Data distribution, like, of a data and the relationship between the characteristics and the goal variable are very important factors to consider. So when choosing an acceptable model, the normality and the correlation are a very important consideration. The correlation and the normality. So if the data is not regularly distributed, if the data is not normally distributed, okay, utilizing a tree-based model may be advantageous. Okay, your data should be normally distributed. You should get a bell-shaped curve. When you plot the data, you should get a bell-shaped curve. So if the data is not regularly distributed, when your data is like left skewed or right skewed, okay, so when these kind of data sets are there, it is the best approach. You go for the tree-based model. That may be advantageous. So the concept of the splits in these models will help you, like, it is less affected by the data's normality, that is a normal distribution. So if the data is normally distributed, the linear model may be perfect. Okay, if the data is not normally distributed, you don't have to go to the linear model, you can go to the tree based models. Okay, so this is how you're going to decide the or which model you want to select for your given data. So when choosing an acceptable model, the strength of the connection between the features and the goal variable is also important. So linear model may be a best option if there are high association with the data, that is a correlation with the data, that you will have to keep in your mind when selecting the model. And the next one is missing values. Missing values in your data set. So your data set, every time we cannot get a clean data, right? Your data might be inconsistent. So what will you do? So the missing values are a very common issue that a data scientist is going to address when he's working with a data set, right? So when missing values are present, what you will be doing is, it's very essential for you to consider a crucial critical questions so that you're going to determine the best approach for dealing with them. Okay, so it's like, it's very important. First thing what you'll have to do is, you'll have to consider whether the missing values are related to the specific event or not. You'll have to check with the data set, where if the vendor is giving you a data set, you'll have to check these values are missing, whether it is specific, it is really, if it is missing, it is not an issue, or if it is missing, it is going to bother the, or it is going to disturb our result. If it is going to have a relationship with the specific event, you are going to like uh, treat that separate category of the data and be more beneficial to use a tree based model. Okay, it will be better if your missing value is a way, it is going to have a relationship with the other features. If that is very important, that value is very important, what you'll have to do is, then you can go and use the split method, that is a tree based model. If a linear model is still required for you despite the missing values, it's important to determine the best imputation technique. If you want to go with a linear model, okay, despite you're having the missing values, then you will have to do the imputation technique. Okay, so imputation technique is nothing but, there are like many techniques, like including, you're just going to calculate the mean value and input in that particular column. And we have the k nearest neighbor imputation also, we can go for that as well. Okay, so this is how you're going to understand the missing values, and on that basis you're going to decide. So by considering the nature of the missing values and the specific needs of the model, the data scientist can select the very good appropriate approach for that particular project. And the next one is feature engineering. Okay, what like feature engineering, like once the process of EDA is complete, okay, once you have completed the exploratory data analysis, it's very important to consider the model family that will be used, right? So whether you're going to choose a tree based model or the linear model or the distance based model is very important. So based on the outliers or the correlation and the distribution and the missing values, you're going to decide the family of that particular model. And this is like, it will help, this process of feature engineering will be a crucial for improving your model performance. So it's like the feature engineering, it involves transforming the raw information into a feature that are more informative and useful for the model. So what is a feature engineering? It involves transforming the raw information or raw data into a features that is going to be more informative and useful for your model. So some standard procedures are there in the feature engineering, like scaling, one hot encoding, and creating new features through combinations or interactions. So you will apply these particular feature engineering and you're going to perform the feature, that is converting the raw data and extracting the features. So scaling is essential for the models that rely on the distance metrics like k nearest neighbor. So you should go for the scaling. Support vector missions, scaling is good. When it comes to one hot encoding, so it is useful for categorical features, so that you're going to allow them to be represented as a binary vectors there. So creating a new feature through combinations or interactions can help you to capture a very complex relationships between the features that you may be missed while by the models there. Okay, so it is very important to note that feature engineering should be done with respect to which model you're selecting, tree based model or a linear based model or a distance based model. For example, decision trees can handle categorical features and it do not require scaling. Okay, when it comes to decision tree, it do not require scaling. So while linear models benefit from scaled features, so you should know which model you're going to select first, then you're going to decide which feature engineering you're going to use. Okay, so then when we are talking about this, for a successful model, we will have to deal with the missing values. So how we will handle the missing values? So I am just going to give some small tips here when it comes to handling the missing values. So here, imputation with the missing values with an unknown category, like when dealing with the categorical variables, like will be more beneficial to the tree-based models. When you're dealing with the tree-based models, unknown, Known, that particular character you're going to give when it comes to the tree-based models. So this is because the tree-based models can handle categorical values, categorical variables, it will not rely on the linear relationship between the variables there. So when it comes to the categorical, you can go with giving the unknown in the place of missing. The another method of imputation with for the missing values is like with mean or median. So for that, in that particular column, you calculate the mean of that particular column or a variable, and you're going to impute the mean wherever the missing values are there. That is one method. And the second method, and the third method is model that can be handled missing values it's like it can be very susceptible, and not handling the missing values can lead to reduced performance, like naive bias. Okay, so it is a model that can handle missing values. So you can use the approach of naive bias algorithm, but the missing values can impact the model's performance. So it should be it should be handled very correctly there. The next one is outlier handling. So how we are going to handle the outliers? So outliers can affect your model performance, as I told you earlier, negatively, and in some cases they can also be a golden feature, okay, which you're removing. The outliers which is there, that can be a golden feature which is going to support your predictive power. Okay, so here are some tips so that you should keep in mind when you're handling the outliers. That is, clipping can be more useful for any linear model. So we have a method called as clipping, as it increases the data normality. For linear models, the main concern is I should have a normally distributed data. So if I want to get a normally distributed data, I can go for this clipping model. So, but it is like it causes some information loss also. You should be careful with it. Then comes transformation, like logarithmic or square root transformation. So I prefer this for most of my work. So this transformation, such as logarithmic and square root transformation, can add a kind of a effect to the values without any information loss. Okay, I always prefer this particular logarithmic and square root transformation. Like it is going to make if the values are not it is not going to wane, it is not, if the information is not lost, I can make them more beneficial for a linear models, and linear models are very simple and interpretable is very easy. So the tree so I can go for logarithmic or square root transformation. The next one is tree based model. So in the tree based models, they generally affect by the outliers, because the idea of the split in them will be most probably assign the outliers to separate splits. So either you can go for using logarithmic transformation or square root transformation and go for linear model, or if that is not possible, you can directly go with the tree based model. Okay, and then comes scaling and normalization. So scaling and normalization, it has impact on different models. Like for a tree based model, scaling and normalization, the decision trees and random forests are not affected by scaling and normalization. So why? The reason is that these models work by splitting the data based on the values of the features. So relative scale of the features does not matter. So when you're using a tree-based model, you can go for scaling and normalization. How it impacts linear model, scaling and normalization, how it impacts linear model. So linear regression and logistic regressions, the linear models, examples I'm telling, they are like highly affected by scaling and normalization, because the like why the normalization is excellent approach for linear models, not the scaling, is because faster training. Okay, normal, I can go for normalization, I cannot go for scaling when it comes to the linear model. So it's like for linear models, I had already told you I need a normal distributed data. So I can go for normalization, which can speed up the training process by reducing the number of iterations required by optimization algorithm, and I can get better scores. So for tree-based model, go for scaling, and when it comes to the linear models, go for normalization. Okay, and when it comes to the distance based models, you can just like scaling is necessary for distance based model. Like when you have for the distance based model, like we have feature importance. Okay, feature importance is very important there. So scaling is going to ensure that all the features are equally important in the model, right? If even if I lose one variable, that is going to impact my prediction. So a feature that with a large scale will dominate the model, and it may lead to biased predictions, or in some other cases to explicitly make one feature dominant by another, scaling it. So I also have distance metric. So distance metric, I will go for scaling. So scaling ensures that the distance metric used in the model is very meaningful. Otherwise, the distance power between the points may be dominated by a single feature with large scale. So you'll have to decide there. Then comes categorical variable handling when you're dealing with the categorical data. So it's like you should, it is a like limited number of values. So categorical variables that take a limited number of values, they are like common in many real world applications like marketing and finances. Handling categorical variables is like very important pre-processing step in ML, machine learning. Like how it impacts the linear model is like the linear models like regression or logistic, it require numerical data, numerical inputs. Therefore these categorical variable should be encoded. Okay, for the linear based model, what is very important, numerical values are important, but you have a categorical data. Okay, you have a categorical data. If you have a categorical data, what you will have to do is you will have to do the encoding. So you will just convert the, you will just have, you use this one hot encoding method. It transforms each of the numeric into a binary vector with a length equal to the number of categories. You will not lose your information. So this method is very useful for the linear models because it creates a separate feature of each category there. And frequency encoding is also there. It is nothing but it is replacing each category with its frequency in the data set. Okay, so this method is also useful for linear models only because it captures the distribution of categories in the data sets, like which can be informative for predicting the target variable. And when it comes to the tree-based model, that is the categorical variable handling, you will go with label encoding. Okay, you will go with label encoding and target encoding. So tree-based model like decision tree or random forest can handle the categorical variables, not like linear models. These models can handle categorical variables without any encoding, but some encoding methods can improve the performance. So it is still more better, right? If I have a accurate one, it is still more better. So to improve the performance even more better, I will go for label encoding and target encoding when it comes to the tree based models. Okay, so then I go with once like you have shared like some of the ideas during the exploratory data analysis and the feature engineering by handling all the missing values, outliers, by doing the scaling and normalization, by handling the categorical values, like you should have a better sense of which model will best fit your data. So it is also important to consider the non-data related factors outside that could influence your decision. Okay, non-data related factors means some ideas what the vendor is trying to tell. He might give you some kind of a, because he is worked on that particular data, collecting the data. So that non-data factors is also going to influence the decision what you're going to make when selecting a model. Okay, so when after you have considered all those, then you will go for deployment consideration. So what is that deployment consideration? So as you consider your model of choice, you have considered one model. It is very important to take into deployment consideration, what are unrelated to the data. You're going to see what are unrelated to the data. Like you might ask yourselves, like what is our data storage capacity? Like if our system has limited storage capacity, like we may not be able to store large classification or regression models. right? Or gigabytes of the data, or the training, it is very difficult. So the storage of and the capacity of the data should be considered before you deploy. And does you'll also have another kind of a questions like, does our prediction need to be fast? Or in real time applications, it's like it's very crucial to generate the predictions as quickly as possible, right? So like for instances, like in the autonomous driving, the road signs must be classified rapidly to prevent the accidents, right? So that all should be deployment considerations should be done beforehand. The storage and the prediction should be fast or not, everything you will have to consider it after you have selected your model. Then usability consideration. So what is this usability consideration? Now that you have covered the different model families, like we have also discussed the best practice for exploratory data analysis and feature engineering, and we have also saw what kind of deployment questions we have, like that may favor one model over another model. So depending on these questions, we will just try with this model and compare it with the another model. So it's time to like develop yourself into a crucial aspect that all the data centers should be aware of this explainability versus predictability. We are just coming to an end. Okay, you should be aware of this explainability and predictability. So it's like one important factor at the end you will have to consider is the trade-off between this explainability and predictability. The like of like when it comes to explainability, let me just talk about explainability first. Explainability is something, it is nothing but it is going to refer to the extent to which uh, we can explain the model's prediction. Explainability is how how it is going to to which extent it is going to refer to our model's prediction. It is going to explain our model's prediction. For example, let's take example of decision tree. So a decision tree is highly explainable model, they say. Why? Because we can easily determine like why it made a particular prediction, because it is following the branches, because of yes no tree, like the node, single node to two branches, two branches, two branches, we are getting the explanation why it has come to that particular prediction, right? Because it is working on if then else, if not this then what, if not this then what. So this is called as a explainability, example of a explainability model. So when these kind of splits are there, these type of models are often referred to as white box models. We say this as white box model. So where there is an explanation for the prediction which we have got. So this is the reason I have come to this prediction. There is an explanation over there in the model itself. On the other hand, we have predictability, which is nothing but it is the model's ability to make accurate predictions regardless of the ability to explain, or the programmer's ability to explain how it arrived to that particular prediction for a given input. We don't have an explanation how did it got that particular prediction or that particular value. For example, neural networks. So the neural networks is very complex. It works like our human brain networking. So we cannot understand, right? Even if we imagine, we just know when I want to drink some water, I'm just lifting my bottle and I'm drinking. But my neurons is sending so many impulses and messages throughout my body. That's the reason my hands and everything is just moving around. If I think about something I want to do, it's just doing that task. In the same way, we don't know how it is happening. The same way, neural network is also very complex. It is difficult to understand why it provides a particular predictions. So these type of models are often referred to as black box, because it is like blind. We don't know the explanation behind it. So we call those models as black box models. So this explainability versus the predictability, it can be demonstrated in this particular, it has been demonstrated in this particular graph here, okay, with various machine learning algorithm. So if you want the explainability, the accuracy is this much. If you see the low accuracy, low to high, the graph is here, this is the accuracy. Okay, so if you see the decision tree, baggy neighbor bias, linear regression, nearest neighbor, so everything is just coming in the form in the low accuracy only, low to high. But the interpretability, if you see, the prediction is good, okay, but the accuracy is less. But when it comes to the networks, the black box models, okay, the black box model, it is not having any kind of an explainability. We don't know how it got that particular prediction, but the accuracy is high there. Okay, but the interpretability is less, explanation is less, but the accuracy is high. So this is like, it is very essential to keep these kind of a trade-off in mind, because there may be many instances like where the application requires like some level of explainability in the selected model. Okay, in case according to your that's what we say, we had talked about, right? Non-data related factors, according to that you should know whether you want an explainability model or a predictability model. So you might require some of explainability in the selected model, which would mean like like opting for simpler models. If you just want the explainability, you can opt for simpler models. Like on the other side, there may be situations where explainability is not necessary for you, and prioritizing the model with high predictability over a simpler one may be more advantageous. So during that situation, ultimately it is very crucial to strike the right balance between the explainability and the predictability, depending on the specific requirement of the application, or the requirement on the data, or the requirement given by the vendor. Everything depends on that. Okay, so this is all about today's explanation. Okay, so